Thank you for having me. It's always nice to be presenting in front of such a big and great audience. As you might have noticed, I'm not Gloria Guidetti, who was supposed to give this speech, but unfortunately she had some travel schedule changed, and unfortunately she cannot join. So I will present in her behalf. My name is Davide Fantozzi. I'm a PhD in material science and engineering, and I work as a material specialist in the group of materials engineering and enabling technologies at Tetra Pak. And I report to Gloria. So the talk today will be about the interaction with big companies and development possibilities for the packaging sector. I'll guide you through this presentation through Tetra Pak's world and our interaction with advanced research centers like GEIC and universities, and then giving an overview of interesting graphene applications for food packaging industry. And so about Tetra Pak. Tetra Pak is a company that supplies end-to-end solutions to our customer. It goes beyond the simple package that you find in the supermarket aisles. We supply solution and equipment for dairy, plant-based, cheese, powered ice cream, beverages, and prepared food. And of course, the packaging and the service as well. So we help our customers to improve their performance, optimize cost, ensure food safety, and so on. So this is a video of a company. This is a company video that shows the high complexity that lays behind what we do at Tetra Pak. Specifically, much of what we do in our R&D goes into the automatic filling machines. So we do sensors and many other technology features that allow our customers to carry out their operations in the most advanced and optimized ways, for example. And so Tetra Pak is a big company. I will give you some numbers. So it's been active since 70 years ago. Tetra Pak employs more than 25,000 people all over the world. Basically, we are present in more than 160 countries. The net sales are around 11 billions. And our equipment in the world produced roughly 192 billion packages every year. Our installed base includes 9,000 units operating in the packaging sector, 81,000 processing equipment plants, and 21,000 downstream equipment in the world. So why is Tetra Pak so interested in exploring new technologies such as graphene? Well, the answer is simple. It's because we want to stay innovative, and an example of this is our eBeam. The eBeam is a part of our filling machine equipment that exploits a beam of electrons to sanitize and sterilize our packaging material before it comes into top contact with the product. And we're very proud of it because this is a technology that before was only seen in laboratories and universities in electron microscopes, for example. And we believe that this makes our package unique compared to the competitors. And competition is indeed quite tough. For example, our customers are exposed to a very large offer, and they might believe that all the packages and products that they see in the supermarket aisle are the same. So we need to stay ahead of our competition, of course, but not only, because we believe that there are other very important challenges that we have to face. Because now there are many aspects that a global industry has to take into account during their development, so like launch of new products. And to mention a few, some very important aspects in this process are the environmental impact or regulations being sustainable. So we want our we want the food system to be sustainable and prevent a lot of waste. To do so, we face many challenges. One example is sustainability, such as recyclability. We want to provide competitive solution, including a complete value chain. We want to have our customer do their operation with their best performance versus costs. Health and safety is, of course, critical and very important, and other manufacturing aspects as well. So over the time, we realized that to remain competitive and innovative, we have to move from an incremental type of innovation, where we focused and invested the most into improving the current products. So we realized that now it's more important than ever to invest more in transformational kind of innovation, where we bring new products that can change the market and can change the field of industry. And as you can see, this is translated in this plot, where we show how much was how our budget was divided during the years in this kind of type of innovations, where in 2018 it was mostly incremental. We expect it to be by 2025 mostly within next generation and transformational innovation. So innovating isn't easy, and we need partners such as the University of Manchester and GEIC and small companies and startups to work together with us. And it might appear that these relationships are unbalanced, because big companies like Tetra Pak have a big impact, stronger structure, a lot of money, and but this is not the reality, and we want everyone to know that this is not what we believe, because we in fact believe that innovation is a team sport. And 83% of innovation and success of new products come from partnership. This is because the industry does not have all the competencies on specific topics, such as graphene, and the university does not have our competence on our equipment. So the only option is working together and equally. So to integrate graphene in our innovation process, over the years, we created a very strong network of innovation, where GEIC and the University of Manchester are also partners, and we are very proud of it. Together, we explored the application with our equipment, packaging material, sensor, and tags. And here are some examples. For example, in our equipment, you might have noticed that our equipment is a big drive in our innovation process, and the graphenes, for example, has been introduced and explored in many applications in our equipment. For example, for its thermal management properties, which is one of the properties that, among others, are quite appealing. And we are also considering other interesting applications, such as smart materials. So we tested and we are exploring conductive plastic components, materials for thermal management, sensing of mechanical components. We have to focus a lot also on sustainable materials. Especially, we have the target of removing PFAS from all our supply chain. And we are exploring anti-corrosion, anti-sticking coatings, graphene paper as heat spreader or heat generation, and a graphene barrier in equipment, such as vacuum retention enhancement or protection of molten polymers. And an important application is in our packaging material. We have been testing this as a packaging material barrier layer, because as you all know, the prospect of graphene being produced sustainably with circular methodologies and with renewable resources, and thus with low CO2 emissions, makes it very appealing. And the application sounds quite on spot, because of the properties of graphene that makes it a quite good environmental barrier. And in terms of upscaling, well, We have been doing it from a laboratory, and now we are testing production scale. And also in terms of costs, we've noticed that graphene over the years has been more and more produced industrially. And with that, also the economy of scale brought a reduction of the price of graphene, so which makes it more appealing as a solution also on the industry. On the health and environment aspects, it's not understood yet. It appears that it will be considered and approved as application case-by-case approach. So we will have to design the products to fulfill these requirements. Other applications are in connectivity, so smaller circuits and sensors and tags, because our market is global and the food chain is definitely far from local anymore. So we have to assure that food safety and quality is maintained. And with that, we have to ensure good integration of the food supply chain. So graphene can be used in these aspects for traceability of our packages, for sensors and printed tags due to its conductivity, mechanical flexibility, sensitivity. Of course, it needs to be low cost and small and flexible, and of course, disposable. So I'm approaching the end of my presentation, and here are a few takeaways that I would like to use to wrap up this presentation. So at Tetra Pak, we believe that innovation is essential. Companies, even as big as Tetra Pak, will not survive without transformational innovation. And startup and also universities and research centers and institutes are a powerful tool and also an asset for the overall industry. So we are very open to collaborate. As we've shown, we do it quite a lot, and we are always open to new collaboration. We want, of course, to have this collaboration to be equal for both parties. So we want you to create an ecosystem of innovation, your own ecosystem. And as far as graphene in the packaging sector, we believe that it has a big value, mostly in equipment, but also in packaging material and in digital technologies. So this was all for me. Thank you very much for your attention, and feel free to come up with questions.
Thank you very much, and thank you very much for stepping in at the last moment for Gloria. Do we have any questions from the floor? No, got no questions from the floor, so it must have been very informative. Thanks very much. But it does, working with Tetra Pak, it has just realised just the amount of graphene applications just for one supplier, and it really does emphasise that kind of working together in collaborative partnerships. What's really been highlighted through these talks in the second session is that kind of industry-led kind of applications, but that collaboration and working with the supply chain, whether that's the equipment supply chain, the material supply chain, to help deliver the end goal, is quite an important aspect of innovation in general. Thanks very much. So that brings together the end of our morning sessions.